Hello, friends. Uh, in continuation of the previous videos, now this is the problem of GATE 2017. As you can see, there is a H pile which is driven into sandy ground. The length of the pile is 7 meter, and the surface area of H pile is given as 3 meter square per meter length. The ground properties are given to you. Groundwater table is 2 meter from the ground level, and above the water table, the unit weight is given, and below the water table, the saturated unit weight is also given. The coefficient of earth pressure K is given as 1, and we need to find out the value of load transferred through skin friction, that is QS. So if you take a H pile, this is the H pile embedded into the ground, and this is the ground level, and the groundwater table is shown ZW equal to 2 meter, and the unit weight here gamma T is 16 kilonewton per cubic meter, and here the saturated is 19 kilonewton per cubic meter, and therefore the submerged unit weight will be 19 minus 9.81, that is the unit weight of water. So it becomes now 19 9.19 kilonewton per cubic meter. So this the properties K value is given as 1, and we need to find out the load transfer through skin friction. So it is subjected to a compressive load, and through a skin friction, what is the load transferred is called the load transfer through unit skin friction, Fs. So US, we can find it out in kilonewton, will be the unit skin friction Fs multiplied by the shaft area. So this is the equation, and therefore Fs for sandy, because this is a sandy ground, cohesionless ground. So the unit skin friction for this will be K times gamma into Z into, that is the vertical pressure, gamma Z multiplied by tan delta. This is the equation for unit skin friction. And when Z equal to 0, Fs will become 0. So at ground level, that is at ground level. And when Z equal to L, that is at the tip, the Fs value will be given as K times gamma into Z becomes the total length. So we can say the Z will be replaced by L into tan delta. So you can draw the pressure distribution diagram very easily. There is the pile embedded into the ground, with the ground level, with the water table, The length of the pile is given to us 7 meter. So this is 2 meter here to here, and there is 7 meters. So remaining will be 5 meter. So from here to here is going to be 5 meter. Is 2 meter. So the pressure distribution Fs can be calculated very easily at 2 meter. Z equal to 2 meter. The unit skin friction will be K, that is 1, gamma value is 60, and Z is 2 into tan 23 degree. So this in kilopascal you can calculate at 2 meter, and at Z equal to 7 meter, you can calculate Fs equal to K, that is 1. Now gamma prime is 9.19. So because it is underwater, under groundwater table, therefore beyond 2 meter, from 2 to 5 meter, it is from 2 meter to 5 meter. The value of Fs will be K equal to 1, gamma prime will be 9.19, and the length of the pile is going to be L minus Z, that is 5 meter, from 2 meter to 2 meter to 7 meter. That is net, it is going to be 5 meter into tan 23 degree. This you can calculate in kilopascal, and then you can plot the variation of Fs over the pile's length. So let us calculate. So if we calculate, there is 13.58 kilopascal, and for the remaining this is 9.19 multiplied by 5 into tan 23 is 19.50. So if you plot the variation, it is going to be 13.58 at 2 meter. So this is 13.58, right? And then from here, 2 meter to this is going to be 19.50. So this is the pressure distribution. So this shows the variation of unit skin friction, Fs. So you can find out the area of this, and having found out the area of this, you will be able to get the value of Fs. So let us find it out. Here it is 0. So for part 1, let us say this is part 2 and this is part 3. So we can calculate Fs now. Fs will be, this will be half into 13.58 58 multiplied by 2. So that is the value of this. So for this particular part, we are having the value. So we can say it is 0. Here it is 13.5. So in between, it is going to be 0 plus 13.5 divided by 2 multiplied by 2. And it is acting over the shaft area, and the perimeter is going to be pi into d. Now d is already, diameter is already given to you, or the shaft area is already given to you. So what you can do it, you can multiply it by the shaft area. What is the shaft area here? Shaft area is 3 meter square per meter length. So for 2 meter, it is going to be 3 meter square into, what is the area? Per meter. So this is 2 meter. So this is for first one, the shaft area, you know the value of Fs plus. Go to the second part. Second part, it is going to be 13.58 multiplied by, what is the shaft area now? The shaft area is going to be 3 square meter, and this is operating over a part of 5 meter, plus the third part is going to be half of 19.5 multiplied by, the shaft area is going to be 3 into 3 square meter per meter length. So it is for 5 meter. So the net value you are getting for unit skin friction. So unit skin friction multiplied by the area. So this gives you the value of unit skin friction. So this is the area, shaft area. This is the shaft area. This is also the shaft area. And these are the values of unit skin friction. So Fs multiplied by the shaft area will give you the value of Qs in kilonewton. So if you calculate this, we can get the value in kilonewton. So let us calculate and find out the answer for this. So this becomes 13.58 into 3 plus 13.58 into 15 plus, this is going to be 19.5 multiplied by 15 divided by 2. So this is going to give you 390.69 kilonewton. So the skin friction, if you want to calculate, this is the how you can easily calculate the skin friction in a H pile. So very simple way we can calculate it. The formula we already know how to calculate the skin friction, and shaft area is already given. So first 2 meter, because it is in dry condition, you will have to take the dry density. K value remains 1 and Z becomes 2 meter and tan 23 degree. So you have calculated it as 13.58, which is shown over here. From 0, it becomes 13.58. And here the unit weight is going to change from 2 meter to 7 meter. That is for a range of 5 meter. So for a range of 5 meter, Fs you will have to calculate it. So Fs is going to be k value 1, 9.19, that is the gamma prime, into 5 into 10, there is 19.50. So you get the variation of Fs over the pile's length, and then you can find out the value of Qs by multiplying Fs with the shaft area. So first 2 meter, it is going to be 3 into 2. Then for this, it is going to be remaining 5 meter, 3 into 5. And for this, it is going to be 3 square meter per meter length. So for 5 meter. So finally, the answer is going to be this. So 2017 set 1 problem has been explained over here, and I hope this point is quite clear to all of you. Now, we will be going to the next problem. So the next problem is like this. We'll take up the next problem. The next problem is 2015 set 2, where you have a pile which is embedded into the ground. The ground properties, it is purely cohesive ground. So ground is cohesive in nature, and this is the value is C is going to change. The for layer 1, which is of 5 meter, the value of C is known to you as 40 kilopascal. And for second layer, which is again of another 5 meter, the value of C is going to change. It is a layered one. It is 50 kilopascal. Then for the third layer of again 5 meter, C equal to 60 kilopascal. So first 40, second 50, third 60, and then fourth again of 5 meter, C equal to 70 kilopascal. And for the last, that is, this is also 5 meter, C equal to 80 kilopascal. So this is the pile. Pile here terminates. So you can just see our pile embedded in the cohesive bed. And the unit weight, gamma, so total length is going to be 10, 15, 20, 25. Gamma equal to 18 kilonewton per cubic meter for throughout for 25 cubic meter. Now, we want to find out here the value of QS, that is the calculate the load transferred through skin friction, that is QS. This pile is a friction pile. As you know, in friction pile, you need not calculate the end bearing resistance. The load transfer through end bending is not taken into consideration, only through skin friction, because it is a friction pile. And you will have to calculate QS by using lambda method. Alpha method, you know that how to calculate the unit skin friction becomes alpha times Cu. Similarly, lambda method, you will have to use it. And the value of this coefficient lambda is given as 0.15 for throughout the layer. So you can this. And the diameter of the pile, dia of the pile is given to you as 0.5 meter. So how will you calculate the skin friction? There is a friction pile. So the value of Qu, the ultimate load carrying capacity of this pile, will be equal to Qs. Qe will be 0. We need not consider this. So it is going to be Qu equal to Qs. So find out the value of ultimate load carrying capacity. Qu equal to Qs will be equal to Fs, that is the unit skin friction that will come into picture, multiplied by the shaft area. Now it is a layered soil mass. All right. Now, using lambda method, we can easily calculate the value of Fs, which is given as the coefficient lambda multiplied by Q naught prime bar plus 2 times Cu bar. This is the formula for Fs. Now lambda is already given in the problem. Now what is Q naught bar? Q naught prime bar is the mean overburden pressure, at the pile's tip. So easily you can calculate this. Here, at this point, this is the pile's tip. So how will you calculate this mean value? That you can always calculate it. So what will be the mean value? It will be gamma multiplied by length of the pile divided by 2. That is the mean value. So the gamma value is already given to me as 18 kilonewton per cubic meter, and the length of the pile is going to be, because 5 layers of each of 5 meter, so 5 into 5, that is 25 meter. So length will be 25 meter divided by 2. So you can calculate this in kilopascal. So calculate this, and having calculated this, you can also calculate the value of Cu bar. What is Cu bar? The mean value of cohesion. Mean value of cohesion for the entire pile's length. or length of the pile. So how much it will be? You can just see 40 plus 50, 90, 60, 150 plus 70, 220 plus 80. This becomes 300. If you sum up. So mean value means you will have to five values. So 300 kilopascal divided by 5 will give you 60 kilopascal. And here it will be 9 into 25. So 9 into 25, if you calculate it, two to 5 kilopascal. So we know this mean value, we know this mean value. Therefore, if you substitute here, you can get the value of Fs. So let us calculate the value of Fs. So here, calculate the value of Fs by substituting lambda, substituting this. So the value of Fs, therefore, 0.15 into Q naught bar is 225 plus 2 times Cu mean value. So this becomes 0.225 plus 120 multiplied by 0.15 gives you 51.75. So here this is going to be 51.75. So Fs is known to me. Therefore, I can find out the value of so here, therefore, the ultimate load carrying capacity, which is for friction pile, it is the load transfer through a skin friction, is going to be 51.75 multiplied by the shaft area of the pile. So the diameter is already known to me. So the shaft area is going to be pi d multiplied by the length, that is the shaft area. So this becomes 10 pi. So let us calculate multiplied by 10 into this gives you 16 to 5.774 kilonewton. Therefore, the QS value for this problem, the pile embedded in cohesive ground, so we have to calculate for a friction pile. This is how you can calculate it. So there is also a very good problem which was asked in 2015. And now the next problem, we can take it. So you can see that nature of the problems, if you know it conceptually, you can attempt any kind of problem. 2014 also, we can see another problem. So we started with 2024, and we have done all the problems that has been asked on deep foundation, particularly on pile foundation. And this problem is of the year 2014 set 2. Here in this problem, you have a pile embedded into the ground. You need to find out the ultimate load carrying capacity of this pile. The diameter of the pile's details are known to you, 0.5 meter diameter, and length is 20 meter. The length of the pile is 20 meter. And it is embedded in cohesionless ground. So ground is cohesionless. Therefore, the ground properties for cohesionless ground is phi 30 degree, and it is in dry condition, so dry unit weight is given to you as 20 kilonewton per cubic meter, and the value of delta angle of wall friction is given to you as 2/3 of phi. So it becomes 20 degree, and K value is given as 2.7, and NQ, the bearing capacity factor, is given to us as 25. And the pile is friction pile. Considering the pile as friction pile, you will have to calculate the ultimate load carrying capacity. Again, the friction pile means it is going to be only a skin friction. So how will you calculate the skin friction here? There is a skin friction that will come into picture. I have already explained that unit skin friction, this will be equal to the unit skin friction multiplied by the shaft area. So, how will you calculate the unit skin friction? It is going to be K times gamma D, because it is completely dry, cohesionless ground, gamma D multiplied by Z. So the vertical stress multiplied by this horizontal into tan delta. That is the value of unit skin friction. So you will be getting at Z equal to 0. That is, at ground level, the value of unit skin friction will be 0. And at Z equal to L, that is at the pile stiff, the value of Fs will be K is 2.7 multiplied by gamma D 20, and Z becomes L. L is also 20, and into tan of delta, that is 20 degrees. So the value of Fs, let us calculate. So this we have calculated very easily. Now, what is the average value? Because it is 0 here, and the value of Fs here, it is 0. So locus of or variation of Fs, here it is 393, 0.08. So the value will be the value of average Fs value will be half of 393.08 kilopascal. All right. Therefore, now you can calculate half into 393.08 kilopascal multiplied by the shaft area. What is the shaft area? Pi d into the length of the pipe. That is the shaft area. So this is 2 teja. This becomes 10. So this becomes 5 pi. This becomes 5 pi multiplied by 393.08. So this gives you 6,174.48 kilonewton. So the value of ultimate load carrying capacity is of this pile, because it is acting as a friction pile, will be 6,174.48 kilonewton. So like this, you have seen that we have started with 2024 and down to 2014, we have been able to calculate, solve all the gate problems on deep foundation. We will continue in the next video and explain you the theoretical concept like this, so that you can attempt all the problems without any difficulty in the examination. Thank you.